Yo, gangsters. How's life? Yo, 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 yo. What's going on? What's going on? How you guys doing, mate? How you guys doing, mate? Devs, we saying? Rayhan, what's up? Swaro, GMB, we saying? Mohammed, yes. Maybe refresh. Rohan, what's up? Finnica, what's up? We saying static? Omar, we saying Unk? What's good, G1? Yo, yo, yo. Miran, what's up? How's life, man? You guys starting school soon, innit? Like 2 weeks or 3 weeks. Hey, yo, these months go quick, man. It's crazy. Yo, Hassan. Morning, Sienna. Third last lesson, yeah. Yeah, I've been playing too much Fortnite. Debs, do people still play Fortnite? That's crazy. Is that still the most popular game out right now? Where time flies, for real. Ethan, what you saying, dude? Bro wants that extra vision. Yo, Mohammed. Rayhan, Fortnite fell off. It's definitely not the same as it used to be back in... Whoa, man, what did it... Came out in like 2017, right? Mate, I feel old. I think it came out in 2017, right? 2016, was it? Bruh, that was the golden age, man. That was the golden age. The Fortnite World Cup as well in 2018. That was crazy. 2017 Battle Royale came out. Oh, okay. So that's when it popped. Good times, man. Now it's 2024. That's crazy. Oh, man. Now I feel like a granddad, man. That's crazy. So what? Now the updates are nice, but it's underwhelming now. Is it? Okay. One thing's for sure is I probably won't be coming back to it. But what would you guys say was better? The OG Fortnite or Warzone in 2020? Which one was better? So Warzone 2020 or Fortnite back in 2018? Which one was the better launch? Because 2020 was during COVID, right? So it was a different time. Didn't even play Warzone 9. You missed out, dude. Yeah, Ken. Rebirth? Hey, yo. It's a hard one. It's a hard one. But, I don't know. I'm more of a COD player, so I'll probably say Warzone was my thing. And yeah, when Rebirth came out, it was moving crazy. So, yeah, man. The MP5 sniper combo was pretty goated, man. But yeah, what we got? We got the friction and statics. Last lesson I introduced you to forces, right? And inclined planes, which was pretty cool. Today I'm going to introduce you to friction, statics. Then at the end, I'm going to remind you guys about the course that starts in 2 weeks. So remember, guys, we're just saying time's going quick, and you guys know that I taught a 10-year-old to get an A star. So I'm going to remind you guys about the course that's starting in September, and then we'll play Kahoot. Innit? All right, cool. Let's do it, mate. Love a bit of merch. Always wear merch, mate. And all the students on my course, they always get merch on if they're on annual. All right, so first thing, guys, is we have to understand how friction works. You've all heard about this word friction, yeah? But the way friction behaves is very interesting because friction as a resistive force is not constant. Yeah? It doesn't act the same all the time. So there's 3 situations I'm going to show you guys. The first situation is we have a box. Yeah, we have a box. And I'm applying a force of 6 newtons to that box. It's not moving. So what must friction be here? So the box is not moving. What must friction be? Exactly, 6 newtons, yeah? Nice. Because it has to balance, yeah? So guys, it can't be 0. If it's 0, then it would be moving, yeah? Then there's an imbalance. If that's 0, then this 6 newtons is greater than 0. It would move, it would accelerate that way. But if it's not moving, remember what we said last lesson, all the forces have to be in balance, yeah? So they must both be 6. Yeah, it's not moving. Movement means imbalance of forces. Not moving means balance of forces. Yeah? Now look at situation 2. I'm going to now apply a force to the same box. Yes, it's the same box. I'm now going to apply a force of 10 newtons. But the object is on the verge of slipping. We call this limiting equilibrium. Verge of slipping means that it's not moving, but it's about to. So what must F be here? So it's on the verge of moving, limiting equilibrium. What must F be this time? So it's still not moving, but it's not moving. So I've still said, Samir, nice. Guys, I have said it's not moving. Yeah? Even though it's on the verge of moving, it's still not moving. Yeah? It's not moving. So it's still 10. Yeah? So it's still 10. They're still balanced. F is still 10 here. Yeah, here F equals 6. Which is interesting, right? So friction is also changing. The surface is the same. So this is same surface. Yeah. Why do I say on the verge? Well, that's a good point. Let's look at situation 3. I'm going to apply a marginal increase in force from situation 2. What is the friction now? So in situation 2, I said that the object is on the verge of slipping. It's about to move, but it's still not moving. But now I'm going to increase the push force slightly. What does friction have to be now? And is the box moving? Or is it still? So Rouet and Abdul have gone with 10. Abdul said yes, it is moving. It is moving. So we need to be clear about lingo here. Yeah? So when you guys see this word or words, verge of slipping, Steven Gerrard, or limiting equilibrium, all that means is friction is at its maximum, and if you apply any more force, the object would start moving. Yeah? And you can do this practically as well. So you guys get an object, yeah, like my graphical calculator, and you put on a surface, yeah, you could put on your arm or something, man like Stevie G, yeah? Now, situation 1 is I'm applying 6 newtons. So right now, guys, I'm pushing 6 newtons. The object's not moving. I'm now applying 10 newtons. The object's not moving, yeah? But now I'm applying 10.1. Can you see it's moving slightly? Yeah? So 10 newtons, yeah, 10 newtons is, this calculator is about to start moving. If I apply any more force, it starts moving like this. Yeah? So don't we also consider static friction? What do you mean by that, Omar? So here I'm just saying friction's friction. Yeah, and we're going to look at surface friction here. So friction, guys, the way friction behaves is it gives as good as it gets up until a certain point. So when you're at the verge of slipping, so let's make a note of this, when you're at the verge of slipping, the object or any more force, let me get rid of this object. Any more force will lead to the object moving. Yeah? In this situation, friction is at its maximum. Yeah? Now, friction will match any force that opposes it up until a certain point. Yeah? So let's write this down. Friction will match any opposing force up until its maximum. And there's conditions on this maximum. Yeah, so you can see in situation 1, friction was 6 newtons because it was not moving. And here, friction was 10 newtons because it's not moving. And this 10 newtons is the largest friction can be because I said that the box is about to start moving. It's not moving yet, but any more force will cause it to start moving, which indicates that friction's maximum value is 10. And now can you see that there's an imbalance? It means that this box would be moving. Yeah? So, just to give you guys other examples here, in the same diagram, you guys don't need to write this bit down. Let's go to situation 1. If I change this 6 newtons, Samir, yes, is 10 going forward. If I change this to 5 newtons, what would friction have been? Based on all this situation that we've just discussed, if I change that to 5 newtons, what would friction have to be here? What would friction be? Based on all the same situation. Andy's going 5, Ariana 5, Gandhi, JMB, good. It would be 5. Yeah? Friction's not its maximum, yeah? It's going to match the opposing force, yeah? Okay. What about if I change it to 15 newtons then? What would it be at 15 newtons? No, it's not going to be 15. Think about the situation I just said. Friction will match any opposing force up until its maximum. Thank you, Charlie. It would be 10. 15, J1 exactly, is above the maximum. Friction has a maximum, like we just said, of 10. If you apply a force bigger than 10, the object's going to start moving and friction will remain at 10. Yeah, so this is now moving. Okay, let's try again. What would friction be if this was 9.9 newtons? Not every situation, Ariana, for this specific situation. 9.9, good. It's not moving. Okay. What if I change it to... What if I change it to 10.1 newtons? What would friction be here? Okay, there we go. So this 10.1 is bigger than the biggest value of friction. Friction can only go up to 10. So it's going to be moving. Yeah, this is specific to this situation. Obviously, guys, friction changes depending on the different variables which we'll be discussing today. Yeah. So this is a very important statement. Friction will match any opposing force until it reaches its maximum. And we just discussed for this specific situation that its maximum is 10. Yeah. Sienna, this is specific to this situation. It could be whatever it wants depending on the surface roughness, which we're going to discuss now. So what determines the value of... Actually, what was that transition? That's weird. I never usually have a transition. Anyway, so what two things determine how strong friction is? What's the most obvious thing that determines how strong friction is? What should be the most obvious thing? Not gravity. What about the surface? Kai, that is true. What about the surface? Sienna, so now this is independent to friction, but yeah, the opposing force would determine its whether it's at its maximum or not, but the roughness of the surface exactly will determine how strong your friction is. Yeah, so if I'm doing it on my top, that will have more friction than my arm if I was in short sleeves, because my forearm, the skin on my forearm is less rough than this jumper, right? Well, actually, I've got hairy forearms, so maybe not. But anyway, the roughness of the surface. Okay. Now, we call this in maths the coefficient of friction. We call this the coefficient of friction. And the symbol for that is mu, mu. Okay? That's the symbol for the coefficient of friction. Now, mu and that, like the Pokemon. Yeah? Now, there's another thing, another factor. For example, say I'm here, yeah? If I'm pushing horizontally, it's really easy to push, yeah? What angle could I push to make this harder? So I want to make this more difficult to push sideways. What would I have to do as well to make pushing this thing that way harder? So obviously you have the roughness of my jumper, but there's also something else. So what angle? Good, Hussein. You need to point down. You have to add weight. Guys, if you push down, raise my elbow, Ishak. Yeah. So guys, if you push down, so now try it. Push down and try and move it. It's way more difficult. Yeah, it's way more difficult to move sideways than here. Yeah. So when you push down, what are you increasing? When you push down against my arm, what is increasing in this calculation? And it's becoming difficult now. What is going up when you push down? Not the friction. I mean, it will, but think about what happens when you push down. There's a special force which opposes when you push down. There you go, Kai. The reaction force. So guys, when you push down, you are increasing the contact force with your arm. So the contact force is the reaction force. So you're pushing down, you're increasing the contact force, the normal reaction. Yeah, that is R. So that's what it's also dependent on. It's dependent on the normal contact force or the normal reaction force, which is R. Okay? And basically, Miran, yes. So, to calculate the maximum value of friction, so this is the maximum, guys, the biggest value friction can be depends on mu and R. We just multiply them together. F equals mu R. Yeah? However, so this, guys, is like the equivalent during the last slide of your 10 newtons. Yeah? So that maximum is like your 10 newtons. Do you remember this situation here? That's this. This is your F max. Yeah? But remember, friction does not necessarily have to be that value, right? If you're just in equilibrium, what did we say about friction? What did we say about friction if you're just in equilibrium? What has to be true about its value? Or potentially true about its value? I mean, it could be zero, Ariana, if it's not moving. But relative to the maximum. Relative to the maximum. Does it always have to be at its maximum? Does it always have to be the maximum if you're in equilibrium? Think about the two situations. Does friction always have to be at its maximum? What's the other situation? So one situation, it was at its maximum. Does it always have to be at its maximum? Vish, good. It can be lower. Yeah, Miran, yes. It could be less. Yeah. So, remember what we said before? Here, it would be 6 newtons. Yeah. But if I change this to 15, it would stay at 10, the maximum. Yeah. Yo, Dahan, what are you saying, dude? So, friction does not necessarily have to be at its maximum. It could be lower. Yeah. So, it could be lower. And here we would say friction would be less than or equal to the maximum. Yeah? Now that is just at equilibrium. Yeah? So, with a bit of practice, guys, it's actually a very simple concept. It's a new concept. You don't do it in year 12, right? So, let's take a look at our question. It says, a box of mass 30 kilos is to be pulled across a rough floor by a rope inclined at 60 degrees to the floor. The Coefficient of friction between the box and the floor is 0.7. So remember, that's the surface roughness. Find the tension in the string when the box is at the point of moving. Okay? Now, what's the first thing we should always be doing? First thing, always. There we give something like this. Draw a picture. Yeah? So we draw a picture. You could highlight what you know, but we are taking a box of mass 30 kg. So if you see box mass 30 kg, what forces should we be adding to our diagram straight away? What forces are we adding straight away? Weight, so 30g, nice. And the reaction force, good. Now that's not equal to 30, it's just R. We're gonna have to figure that one out. Now it's being pulled across a rough floor by a rope inclined at 60 degrees. So it's being pulled this way by a rope, which we're trying to find the tension, acting 60 degrees to the horizontal. The coefficient of friction between the box and the floor is 0.7. Find the tension. So what force, the only force, am I missing here? What force am I missing here? The friction force, right? Because it's a rough ground. Now, which way is friction going to point? Which way does friction point? Left, Ariana, good. It always acts in line with the surface and away from the direction of movement, yeah? Now, if I tell you that the box is about to move, it's not moving yet, but it's about to move, is friction at its maximum or not? It's about to move, but not yet. Any more force, it would lead to it moving. Is it at its maximum? Yes. See, there you go, guys. It's actually not as hard as you think, right? So this is situation 2. Yeah? You're at the point of slipping. You're not moving yet, but this is the first point at which friction achieves its maximum. Yeah? So this is F max, which means we're going to use mu r. Yeah? Now we know mu is 0.7, so we're going to write 0.7 r. Yeah, that is F max. That's what we write on the diagram. And now, yeah, what we're going to do is we're going to do the same things that we did in the last lesson. What is the most important thing we need to do here? What is the most important thing we need to do here? First, 0.7 times 30g. What's that, Omar? Oh, we don't know if r is 30g yet. We need to resolve, right? So guys, every force needs to be pointing up, down, left, right. So T, we're going to do that triangle of forces. Nice. What is this force going to be when you resolve it? What is that force going to be? Nice, JMB. So you're basically all just deciding, Amberjeet, nice, if it's cos or sine. Yeah, it's going to be cos, that's the adjacent. So we're resolving tension, adjacent, T cos 60, and this will be T sine 60. Boom. All right, now we said that the object is not moving, right? The object is not moving. So what has to be true about the left and the right forces if it's not moving? What has to be true about the left and the right forces if the object is not moving? They're equal. Good. So that's what we do. We're just going to equate them. We're going to look at the left and the right. And we are literally going to say that they are equal. We're going to say 0.7r equals t cos 60. Now guys, cos 60 is a half, so we just get a half t. Okay? Tick them off, we have used them. Okay, I'll color code it in blue so you can, the ticks in blue so you can see it. Which actually means we can say t is 1.4r. What is this starting to look like to you guys? Can you kind of predict what we're going to end up doing here? Should be giving you vibes of something. in terms of how we're going to solve this problem. Nice simultaneous equations, right? Because now we're going to look at up equals down. Yeah, looking at the up equals down, we can see r, which is pointing up, and t sine 60, that is also pointing up, must equal what's pointing down, 30g. And now we're going to solve, yeah? So, sine 60 is root 3 over 2, so we get r plus root 3 over 2t is 30g. And from here, we're just going to solve it. Yeah, we're going to sub it in exactly. So we're going to sub in that t value. And then we, I guess, just factorize things out. So we get r plus root 3 over 2 times 1.4r is 30g. Now with the talk internet. Factorize out r. We get 1 plus root 3 over 2 times 1.4 is 30g. And then you do the division. Do you guys want to type that in? So that's r. Remember, you're going to use 9.8 for... you can use 9.8, Mike. Where do I get the 1 from? Factorizing out r. When you factorize out r, you're left with the 1. What we got? So we got 30 times 9.8 over bracket 1 plus root 3 over 2 times 1.4. Okay, cool. Now this is not the number we were looking for, right? Omar, don't use 9.81 in maths. So we don't need to round it just yet because we're going to use that to work out tension. Yeah, I wasn't interested in this. So now we can work out tension. Remember guys, here we're just going to times our answer by 1.4 and then we're going to round it. So to 2 significant figures, 190, and that's it. Think about it guys. Did we do any really hard maths here? We drew a triangle, we did SOHCAHTOA, and we said up equals down and left equals right and solved simultaneously. Yeah? Is the maths actually difficult here? I would say no. Yeah, the maths in year 13 pure is going to be crazy, but the maths, the actual computational maths that you do in mechanics is not crazy. Yeah? CGW, I feel like you need to go back to see why I got that division, because it's just equating up equals down. Yeah. Okay, now, can you guys guess how many marks a question like this would be in the exam? How many marks would you say? Man, like Ishak, you know. When you invite me to one of your restaurants, man, come on, I'm hungry. Hey, yo, that's Ella's more on the right line. Guys, a question like this could be worth 7 or 8 marks in the exam. It's worth a lot. 1 mark for Lun Gang, of course. But in mechanics, a question like this can be 7 or 8 marks. Yeah? It's actually more individual steps. They're not difficult steps, but there's loads of mini steps. Yeah? So it's worth a lot of marks. Yeah? A would be on the high end, but 7 for sure. Yeah? What's the highest mark possible in maths question? I've seen a 15 mark question, Abdul. It's 14 marks. Maybe 14. It's like an integration question. Alright, Ishak, message me. Message me. I need to come to Amelia's to check it out. This was my bid man interview. My guy, come on. Okay, so let's continue this whole practicing. So not everything that I do today, guys, is going to involve friction, but check this out. It says a paracord mass 6 kg is attached to one end of a light inextensible string. The other end of the string is attached at a point O. You can see that up here. There's a horizontal force F applied at P. The particle P is held in equilibrium under gravity. Find the tension. Okay, so read it again and let me know what forces we can add to our diagram. Now, don't worry, no circular motion, man. NJ, G, so nearly 6G, yes. So 6G for the weight. And Ariana said tension. So here's my string. Guys, which way does tension point? Towards O or towards P? Which way are we going to point tension? And be careful about saying R, guys, because there's no reaction at P because it's not resting on a surface. Yeah. Now, guys, remember tension is away from object. We are discussing P, right? So we have to point it away from P. Yeah, if we're talking about, I don't know, the pulley at O, if there was a pulley, then it would point away from O. But here we're talking about P, so it points away from P. And that's it. Those are all the forces here. What do we do next? What's the next thing we're going to do? Nice, CG. We resolve. Yeah, and in this case, it's tension. This force is not pointing up, down, left, or right. Yeah. Now be careful, there's no friction here. P is not resting on any surface. Now tension is pointing you to the left and is pointing you up. We're doing that triangle. Alright guys, what would this force be? Just doing some triangles and that. Nice, Jay. Eddie, nice. So it's sine. Lois, nice. So it's sine, isn't it? That what I just pointed at is opposite 30. So T sine 30. And this one then would then be T cos 30, right? Done. Now, by just observing, what does it say? Find the tension in the string and the value of F. So if I want to find tension, just looking at that diagram, should we do up equals down or left equals right first? Remember, we're in equilibrium, so it's balanced, balance. Yeah? If I just want to find tension first, should we do up equals down or left equals right first? Eddie, good. Up equals down, because that is immediately going to allow us to work out T, because that's then the only unknown, right? All right, so T cos 30 is 6G. So this is looking at the up equals down. Now in your calculator, guys, what we're going to do is we're going to do 6 divided by cos 30 and then write G next to it. What's 6 divided by cos 30? 12 root 3, like 4 root 3 or something. 4 root 3, maybe. 4 root 3G. Oh, daddy, let's go. Come on, Dave. Who needs a calculator, mate? Oh boy, let's go. 4 root 3G. All right. Now when we look at the left and the right, we have T sine 30 is F. And that's very simple because T, we know is 4 root 3 times sine 30, which is a half. Exactly. Don't forget your G actually. So you get 2 root 3. Neil does calculation. All right, there we go, mate. This question would not be 7 or 8 marks like the last one. This would be more like a 5-mark question in mechanics. But there you go, guys. Would you say that's a hard 5-mark question? In normal math, in year 13 integration, 5 marks would be a lot of computation. Yeah, nice one, Sienna. It just takes a bit of practice, that's it. Like, it's still not much. Yeah, guys, trust me, mechanics is very, very generous. Yeah, can't lie, it might be easier than a GCSE one. Or like GCSE physics. Yes, Hassan, you can leave your answer in terms of G. In the exam, they'll tell you what they want you to leave it in terms of. All right, check this question. We have a smooth bead Q is threaded on a light inextensible string. the ends of the string are attached to 2 points, A and B, on the same horizontal level. The bead is held in equilibrium by a horizontal force of magnitude 10 newtons, acting horizontally. The bead at Q is vertically below A, and we have an angle of 45 degrees. Find the tension in the string and the weight of the bead. Okay, so what are we saying here, guys? What are we gonna fill out in our diagram? If anything, I probably prefer to move this down slightly. So a bit more space. Give me some space, mate. Weight. Now, what are we going to label for the weight? Because I haven't actually given you the weight. What should we write? So, Shristi, you said mg. What do you guys think? What should we label as the weight? Okay, so Omar says W. JMB agrees with Shristi with the mg. Now, in the question, they want you to find the weight. They don't want you to find the mass. If they want you to find the mass, you need to write this in terms of m. But they just want the weight, which is inclusive of g. You only need to use w here. Yeah? So just be careful about what the question says, because what students do then is they use mg, they go and find m, and then they get the question, well, they lose a mark. Yeah? They only want the weight that's inclusive of g, so we don't only need to use w. All right. What's the next thing we need to write down here, Mike? I think there's only one more thing. Tension, yeah. Now, how do we label the tension here? Is it T and T, or is it T1, T2? What would it be in this case? Is it T? Are they both just T, or are we going to label them as different, T1 and T2? So it's dependent on the question, right? Shristi, what do you mean same? Okay, so the question is, are they different strings or are they both the same string? So answer me that now. Are they both the same string or is it two different strings? Yo, Justina, what are you saying, dude? How's life? Different. Okay, no, they are the same. Find the tension in the string. Yeah? The bead is being threaded on a string. It's one string. The ends of the string is all singular. Now, what is this? It's a bit of like textiles back at GCSE. Do you know when you think of like you have a needle and you thread the string through that little hole and you can never do it, right? You have to like lick the string or something to get in. I could never do it. But that's what it's doing. You're threading one string through a bead and then you have one string. So for that, because it's one string, we use T and T. Okay? That's fully complete. What do we do next? What's the next situation? So always look out for the keywords, innit? We resolve, like normal. Nice. So we're going to do a big, well, maybe do a better triangle than me. So this would also be 45 degrees. What would this be? Nice, it's the opposite, right? It'll be T sine. It's opposite to that 45. Try not to sneeze, man. T sine 45. Now, obviously in this specific situation, T sine and T cos 45 are the same value, but we need to make sure that in general we write it down properly. Now, I do give you the same value. Sine 45 is root 2 over 2 T, and this is root 2 over 2 T. It's an isosceles triangle. So we don't need to use that anymore. Okay, so if I want to find the tension first, should I use the up equals down or the left equals right? Which one should we do first? Sienna's gone with left equals right. I agree with you guys, nice. So let's look at the left equals right. What's pointing to the right is root 2 over 2t must equal 10. What does that give you? Like 10 root 2? Is that 10 root 2 newtons? I think. Let's find the first bit. Easy peasy squeeze 11. And then we're gonna, nice. So up equals down. T and root 2 over 2t equals W. Yeah? And that's it. So, you know, you could type that in separately. So we're doing 10 root 2 plus root 2 over 2 times 10 root 2. What'd you guys get there? 5 times 2, 10. 10 root 2 plus 10. 10 plus 10 root 2. Something like that. I think. Ah, sick. I mean, I'm so tempted to factorize out 10 here to make it look nicer. You don't have to do this. I just think that looks better. Okay. Question like this again, 5 marks. Yeah, I mean, I threw you guys straight in the deep end with that first question where we had to do simultaneous equations, but why not? Yeah, that's a W, mate. That's a W. But I'm basically proving to you guys, like, you know, friction, statics, equilibrium, all of that stuff, they're not very difficult. Yeah, you don't think of it as very difficult. Yes, Shusti. Weight is in newtons. Mass would be in kilos. If you wanted to find the mass here, you just divide it by 9.8, which is what you would have done if you wrote mg instead. Yeah? All right. The figure shows a small box of mass 20 kilos pulled by 2 light inextensible strings along rough ground. The tension in the rope inclined at 25 degrees is 40 newtons, and the one at 60 degrees is 120 newtons. The box is modeled as a particle experiencing a constant frictional force where the coefficient of friction between the box and the ground is 0.3. Determine whether the box remains in equilibrium. Okay, so now we need to determine whether the box moves or not. I haven't given you as much information as I usually do. Yeah? So, yeah, we have 2 tensions. We don't have to label them as T1, T2 because I've given you 120 and 40. Yeah? So, what's the first thing we do? Just go about the normal process here. What's the first thing we do? Weight, always. Rayhan, we will resolve. We'll do that in a second. So we have 20G, and what else? Ariana, yep. So we got reaction. All right. Now, what don't we know here, which if we did would make the question a bit easier, or a lot easier? F max is to do with the friction, Shristi. What about the friction don't we know? On initial observation. What don't we know on initial observation? Coefficient we do. We have 0.3 given in the question. Good, JMB. The direction. Guys, when you look at this, is friction this way or is it this way? We don't know. We have to decide that for ourselves. Yeah? Through resolving. So we're not going to put F anymore. We can't do that just yet. We need to do our resolving and figure it out. Yeah? So, let's do it, mate. Let's resolve. What would this side be? sine, good, and the other one will be cos. So let's do that for both. So this will be 40 sine 25, don't need that, 40 cos 25. Let's do the same thing with the 120. 120 cos 60, 120 sine 60. Okay. Now what can we say? What should we work out next? What would be a good idea to work out next? Sienna, good, R. Now the reason, guys, we should work out R is because friction depends on R. Yeah? So we're trying to determine if this object moves. Well, that's going to be determined on friction. We don't know which way friction's even pointing. So let's work out what R is, which influences that value of friction. So yes, we're going to look at the up equals down first. What's pointing up? R and 120 sine 60 and 40 sine 25 equals 120G, 20G. So you're going to move all of this to the other side, and we're going to take R and just round it. Yeah, we're going to round it. So let's do it. So 20 times 9.8, whoops, minus 120 sine 60 minus 40 sine 25. So about 75. Cool, newtons. All right. Now, just by observing, how can we determine which way the box wants to move? How can we determine which way the box wants to move at the moment? Which horizontal is greater, Vish? Good. So what we now need to do is we need to observe the horizontals. We're not going to do an equal situation. We're just going to type them in. So 120 cos 60 is actually 60 newtons if you type it in. And 40 cos 25 is what? 40 cos 25 is about 36, we're going to say. Which way is friction going to point then? So if this is 60 and this is 36, which way is friction going to point? It's going to point right, because 60 is greater than 36. Friction is going to support the right side. Yeah, it's going to oppose that 60 newtons. What about friction do we now need to calculate? What about friction do we now need to calculate? Nice, Sienna. The max. We need to determine if friction's maximum is able to counter the difference. Can you see the difference between 36 and 60 is 24 newtons? We need to determine if friction is able to counter that. Is it able to support the 36 enough? So, F max. Remind me, how do you calculate F max? How do we calculate F max? Mu R. Mu times R, which we worked out to be 75. What is that? 22.5. Is it enough? Is it enough? So the biggest friction can be is 22.5. Is it enough to keep the object still? Is it enough support? No. These two together is less than 60. So we're going to say 60 is greater than 36 plus 22.5. Therefore, the box does not remain in equilibrium. So I write equilibrium like that. In the exam, write it properly. Yep. But yeah, this is an example of another 7-ish mark question, 7 or 8 marks. Again, the actual maths, if you look at the individual maths, guys, it's not hard. But conceptually is all you need to understand. And here, this is the best example of, going over this question. It will really help you understand how friction works. Yeah? If you do it step by step, you can get 4 marks. In general, that's how it works, Rayhan. All right? Okay. We will do Kahoot, but guys, I'm just every second lesson of the week, I'm just gonna remind you of the course that starts in September. It's just gonna take me 5 minutes because a lot of you might have seen it already. Yeah. So just to remind you, what's starting in September? We have the full year 13 course, 108 hours of lessons, 72 exam style homeworks, monthly assessments. Now there's 2 packages. There's the pro package and the standard package. The only difference is that the pro package gives you a personal mentor. In fact, loads of the old year 13s from last year are now applying to be a mentor. So they'll be the ones supporting you in your journey. For year 13, they will have all got an A star, by the way. Yeah. The live video is not on YouTube, right? It is Rayhan, but it's private link. Just a comparison, guys, between what we do here at My Headspace and traditional maths tuition. We're out here changing the game. So depending on the level of experience, you're looking between £25 an hour and £200 an hour for a highly experienced professional for tuition. As you can see here, guys, as I showed you last week, you have a wide variety of individuals charging way above £100 an hour, and on average about £60 to £80 an hour for one-to-one tuition, which over the course of the year can total close to £5,000, and that's based on 2 lessons per week, which is what I provide you guys. Yeah, so about £5,000 per year. And on top of that, you have to select the tutor, you have to schedule the lessons, manage the timetables, few reviews to base your judgment on. You don't really know how they teach already, whereas me, you can see everything on YouTube, Instagram, TikTok. Sessions aren't recorded when you do one-to-one tuition. You don't get extra study materials, and you get very limited review of past lessons. So man, that's based on 2 lessons per week if a tutor charges just £60 an hour. Yeah. So I'm actually doing on the low end. Yeah, but as you guys may have shopped around, there's a lot more. Yeah, tutors don't really charge £60 an hour, inflation and that, Rishi Sunak and that. So that's why we created My Headspace. This compare value. So like we just said, for a tutor charging £60 an hour for 2 lessons a week, you're paying about £5,000 for the year. And if you want a really experienced tutor, you're charging upwards of £8,000 for the year. Or you could choose us at My Headspace, where it's £810 for the whole year. Yeah, 5 times cheaper, or £1,000 if you want for the whole year if you want a mentor. So to have a mentor help you for the whole year for 8 or 9 months, you're just paying an extra £200. That's it. Yeah. So it's 5 times cheaper, but also because you guys are on the summer course, we're going to give you an extra 40% off. So it works out for the whole year, £400. Yeah. So, please, I don't really need to say much, right? So £400 for the whole year, it works out to like £3 or £4 an hour. And if you want a mentor, yes, £600 for the year. Yeah. So it's still that £200 difference, but you're getting someone to help you one-to-one outside of lessons with me for the whole year. All you need to remember, guys, is this code word summer 2024. Summer 2024. And you have protection. You have a 14-day full refund guarantee when the course starts. So if you pay now, in September when the course starts, you have 2 weeks to decide. Yeah. As a kid, there's a link in the description. I'll repost it for you guys. Yeah. Now, why stop at just maths? Yeah. You have all the subjects. So if you're doing year 12, I don't know why Dario's on there, to be honest. That would be me. Dario's doing year 12. I'm doing year 13 maths. Laura for biology, Brooke for physics, and Davinder and LaJoy for chemistry. All of these guys are top G's when it comes to their subject. You can see LaJoy went to Oxford, did chemistry, got her first. Davinder has a PhD from UCL, got his first class chemistry UCL as well. Brooke went to the USA to study physics, then did planetary science at UCL, getting top grades in all of them. And Laura used to write papers for exam boards. And also there's Louis. Louis will also help you with your applications to university, the uni course prep. He did his bachelor's at Oxford and Cambridge in English. He's also doing a PhD right now. This guy is seriously very qualified, mate. Then there's the Ultimate Pass. There's the Ultimate Pass, which gives you access to all 3 subjects. We'll basically look after all of you for all of your subjects if you're interested. And here's what it looks like. It works out to about £2 to £4 per hour if you want all the subjects, yeah? But you don't have to pay it all up front. We will break it up into installments. You can do it up into 4 installments if you want, yeah? So it's up to you how you want to do this. And this is for the Ultimate Pass. Yeah, if you wanted all 3 subjects, this is what it would look like if you wanted to pay today, broken up into 4 pieces, yeah? Exactly, Sienna, that is for Pro, as you can see here, yeah? That's for 3 subjects, which is a limited time offer. So guys, all you need to do is message the code word summer 2024. If you guys have any questions, you can ask me. And this is the timetable. If you guys, the link to which is actually in the description. All you need to do is click this link. It will take you to WhatsApp. And it will have the code word on there already. There's also the number in there right at the bottom. But essentially just click that. It will take you to a WhatsApp conversation with my team and you can ask them any questions. So for chemistry, guys, you have AQA and OCR. If you have any question about biology, physics, you can ask my team. Yes, there is assessment every month, yeah, to recap all of the things that we did in lesson. What happens if we weren't available for the scheduled time lessons? Well, as a kid, everything's recorded for you, right? So you can rewatch everything. So that's the beauty of this product, guys. You can just rewatch as much as you want, right? For the whole year. All right, cool. So on that note, should we play a quick Kahoot, mate? If you have any questions as well, you can ask me. Well, we lesson 6, right? Yeah. All right, let's do it. And what's up, TikTok? Sorry, I'm not looking at this TikTok screen, but if you want to join Kahoot, just come on YouTube, innit? I'll put the code in the chat, but I'm not interacting on TikTok. I'm interacting on YouTube. I'm going to put the code in... Nice, Sienna. Ayo, year 13 is going to be lit. And as you guys have seen, like, I trained a 10-year-old to get an A* in maths. What is the code? 5563831. Okay. Let's go. Let's go. Let's go. Alright, I'm in. What is 1 bracket divided by 1 divided by 0? Who is that? I'm not sure, Gabby. I don't see the Kahoots myself. There's always a curveball question where it's got nothing to do with maths. Abdul, what does that even mean, dude? 1 bracket divided by 1 divided by 0. That didn't even make sense, dude. What is 1? Oh. Well, the whole thing's undefined because you can't do 1 divided by 0, right? So by just putting 1 divided by 0, the whole problem is undefined. Guys, we got like 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. But 1 divided by... Yes, that is true. But when you consider 0, you have to look at limits. Hey, yo. So it doesn't look like this... oh, maybe you'll get harder, I'm not sure. It depends what Dom's put for us. Definitely don't need 30 seconds to do this, though. This timer should end, like, now. Hey, yo, who still hasn't answered the question? You guys are moving slow, mate. The timer will end once everyone's, like I said, if you're on TikTok and you want to play Kahoot, you need to come on YouTube. Alright, got it? Hey, yo, mate. I don't even know what that is, but anyway, I'm on top. Can I be a tutor for A-level maths, further maths if I have the A-star maths and A? Yes, man, Raj, of course. Just apply through the website, innit? Alright, next one. Work out 3/4 of 32. Oh, it's a slider. I was first. 100%. Come on, guys, you can do better. You can do better. Manraj, 1 sec. Here. Nice one, Manraj. Only 27 of you got that right. That's crazy. Ayo, you guys need to do better, man. It's not looking good. It's not looking good, bruv. E to the high pi plus 1 is crazy. How'd you get that syntax? That's wild. Alright, it's another slider. Double points. Ah, for God's sake. Oh, I know. I've been practicing. I've been practicing these. Zayn, am I going to do any further maths lives, videos? I'll definitely upload some videos on TikTok. I don't have a course for it yet because I need to hire another maths teacher full time to help me out. But further maths will come, but whether... There won't be a course, but maybe cram sessions, Easter revision, that kind of stuff at the end of next year, but not starting in September. Also, keep an eye on TikTok. I actually recorded a further maths video the other day. It will be coming out very soon. So C is 100, X is 10, and then 2. I couldn't select 222 in time. It's not looking good. Alright. So, guys, you're not doing very well. I'm absolutely destroying you guys. Alright, question 4. This game is bookie. Double points. Arrange the stations by passenger numbers with the highest at the top. Oh. Oh. Okay. Oh, because I'm start further maths this September, one in tips. What year are you going into, Zane? Like, have you already done normal maths? Or are you going into year 12? Man, Raj, yo, London rent is crazy, man, Raj. You should have applied to Middlesbrough University or something. Alright, so do I really need to explain how to put numbers in order? I don't think so. Liverpool Street is obviously the highest there. Alright. My brain left me. It's the pressure of the numbers. What? I'm not first anymore. Ayo, nah, that's crazy. How's that possible? Ayo, Hassan. Nah, Hassan's cheating for real, man. How's that possible? Alright, last question. Yo. Find the diameter of the circle with circumference 18 pi. I was first, surely. Hey yo, surely, mate. I'm gonna beat Hassan. I'm gonna beat Hassan. There's no way Hassan wins this. Nah, Hassan, I think I got you, mate. Actually, there's no way. What do you mean? I think I got you. Bruh, let's see. Who put 9? Who put 6? Ayo, nah. You guys are cooked. That's not looking good, mate. This guy, man. What even is that? No! Oh, it was so close. Nah, this guy is cheating, man. There's no way. There's no way, man. Unbelievable. Unbelievable. W to Hassan, begrudgingly. But yeah, guys, remember, now because I got Birmingham for econ, but switch KCL for maths, and now I'm homeless. Yo, man, Raj, well, we got you, man. We got you. My studio is next to King, so come say hello one day. So, guys, if you do want to join my course in September, or the other courses as well, just click this link, have a discussion with my team, and they'll be able to discuss options with you, yeah? But Abdul, I'll read that in a second. But otherwise, guys, I will see you all on Monday, where we'll be introducing a bit of statistics for you guys. So have a nice rest of your week, and I'll see you all on Monday. Yeah. See you guys. Nice one, Rio. Odd question, but is f of x equals 2 the same as f of x is 2x over x? Then it becomes a bit philosophical, Abdul. Like when you have 2x over x, as x tends to 0, you know, the limit function is still 2. Yeah. So into 2x over x, you can't substitute x equals 0, but its limit function is still 2. Yeah. So it becomes a bit philosophical, man. But yeah. All right, guys. Well done. I'll see you all next Monday. Yeah, man, Raj, next to Strand campus. I'll be there. We're in Aldwych. If you Google my space location, you'll see. Yeah, come on, let's go. Alright guys, I'll see you all on Monday, mate. See you later. Peace out. Nice.